NASA just unveiled something that has cosmologists reeling, their models crumbling under the weight of new data. The edge of the observable universe isn't what we thought. It's not a faint, fading horizon where light simply runs out. It's alive, chaotic, and brimming with secrets that defy everything we've built our understanding of reality upon. The latest deep space surveys, powered by cutting-edge telescopes, have mapped structures and phenomena that shouldn't exist. Galaxies too massive, too early, voids that pulse with inexplicable energy, and hints of something beyond, tugging at the fabric of space-time itself. This isn't just a tweak to our cosmic story, it's a rewrite of the entire book. The universe, it turns out, might not be a singular, tidy bubble. It could be a jagged, fractured piece of something far stranger, something that challenges the very nature of existence. Let's dive into this cosmic unraveling, because what's emerging from the data is both breathtaking and unsettling. The first shock came from the deepest images ever captured, peering back nearly 13.8 billion years to the universe's infancy. We expected to see a sparse scattering of primordial stars, faint whispers of the Big Bang's afterglow. Instead, the data revealed cosmic juggernauts, galaxies with the mass of 1 trillion suns, fully formed when the universe was barely 200 million years old. That's like finding a sprawling metropolis in the middle of a prehistoric desert. These galaxies, blazing with intense star formation, are packed with heavy elements, metals forged in stellar furnaces that shouldn't have had time to exist. Our models predicted a slow, gradual build-up of stars over billions of years. But these cosmic titans are screaming that the universe hit the ground running, assembling complexity at a pace that defies physics as we know it. One galaxy, catalogued in a recent survey, hosts a black hole so massive, 50 million solar masses, that it would have required a star-forming frenzy impossible in the scant time since the Big Bang. How do you build a cosmic monster like that in a universe that's barely begun? Scientists are scrambling for answers, and the leading theory is as wild as it sounds. Some researchers now propose that the early universe didn't follow the script we wrote. Instead of stars forming first, vast clouds of primordial gas might have collapsed directly into black holes, bypassing the stellar phase entirely. This direct collapse hypothesis flips our understanding of cosmic evolution upside down. Imagine the universe as a stage where the actors skip rehearsals and jump straight to the finale. These black holes, born in the universe's opening act, could have seeded galaxies at breakneck speed, pulling in matter and igniting star formation far earlier than we thought possible. But this theory raises a deeper question. If black holes formed this fast, what else was happening in those first cosmic moments? The data suggests the universe wasn't a calm, uniform soup of particles. It was a roiling cauldron, churning out structure and complexity with reckless abandon. And that's just the beginning. Because the edge of the universe holds something even more disturbing. The observable universe, that 94 billion light-year sphere we call home, was supposed to be roughly uniform, a smooth distribution of galaxies, clusters, and voids, shaped by the gentle ripples of the Big Bang. But the latest surveys reveal a cosmos that's lopsided, uneven, and possibly pulled by forces we can't see. Astronomers have detected density anomalies at the largest scales, where galaxy clusters clump together in ways that defy our predictions. In one region of the sky, mapped in exquisite detail, galaxies appear to be streaming toward an unseen point, as if drawn by an invisible gravitational hand. This cosmic flow stretches across billions of light years, far beyond what random fluctuations could explain. The data hints at a massive structure, or something else, lurking just beyond the observable edge, exerting a pull that warps the very fabric of space-time. Picture a cosmic tide, dragging entire galaxy clusters toward a hidden shore we can't yet see. This isn't science fiction. It's science fact, and it's forcing us to confront a chilling possibility. The universe might not be alone. What could be out there, pulling at the edges of our reality? Some theorists suggest a gargantuan structure, a supercluster or cosmic wall, so vast it dwarfs anything we've ever seen. Others propose something even more radical, a gravitational echo from another universe, brushing against ours in a vast multiverse. The idea of a multiverse isn't new, but the data is starting to give it unsettling weight. Patterns in the cosmic microwave background, CMB, that faint glow from the Big Bang, show anomalies that don't fit a single universe model. There's a peculiar cold spot, a region of the CMB that's colder than it should be, spanning billions of light years. Once dismissed as a statistical fluke, this cold spot now aligns suspiciously with the galaxy streaming patterns observed at the universe's edge. Could it be a scar? A point where our universe touched another? Some physicists argue it's evidence of a bubble collision in a multiverse, where universes bump and bruise each other, leaving marks we can detect. If true, the edge of our universe isn't just a limit, it's a boundary to something else entirely. But the discoveries don't stop there. The universe's edge is revealing secrets about time itself, and they're shaking the foundations of physics. When astronomers study the light from distant supernovae, they're looking back billions of years, watching explosions that happened when the universe was young. These light curves, which track how supernovae brighten and fade, should follow predictable patterns based on Einstein's relativity. But the data shows something eerie. Time itself seems to behave differently at the universe's edge. Some supernovae appear to evolve faster or slower than our models predict, as if the flow of time was stretched or compressed in the early universe. This time dilation anomaly suggests that the expansion of space-time might not be as smooth as we thought. Could time have flowed unevenly in the universe's first chapters? If so, it challenges not just our understanding of cosmic expansion, but the very nature of time as a constant. The implications are dizzying. A universe where time bends and warps in ways we can't yet grasp. These findings tie into a deeper mystery, one that's been haunting cosmologists for years. The Hubble tension. Measurements of the universe's expansion rate don't agree. Data from the CMB suggests an expansion in rate of about 67 kilometers per second per megaparsec, while observations of nearby galaxies clock it at 73. 9% discrepancy might seem small, but it's a crack in the foundation of cosmology. The new data from the universe's edge suggests this tension isn't a measurement error, it's a clue. If time flowed differently in the early universe, or if unseen forces are pulling at the cosmos, the expansion rate we measure today might not match the one etched in the CMB. Some theorists propose that dark energy, the mysterious force driving cosmic expansion, isn't constant. It might vary across space and time, creating ripples that distort our measurements. Others suggest an even wilder idea. The universe might be a simulation, its parameters tweaked in ways that leave these inconsistencies as artifacts of the code. Either way, the edge is telling us that our cosmic clock is ticking strangely. Now let's talk about the structures that shouldn't exist. Deep in the data, astronomers have found cosmic behemoths that break every rule. 1. A vast filament of galaxies stretching over 12 billion light-years is so massive it challenges the limits of gravitational assembly. Standard models say structures shouldn't grow larger than about 1.2 billion light-years, given the time since the Big Bang. Yet here's something 10 times that size, a cosmic leviathan that spans a tenth of the observable universe. How does gravity pull together something this immense in just 13.8 billion years? It's like building a mountain range in a day. Some .invoice researchers argue that cosmic inflation, the rapid expansion in the universe's first moments, allowed fluctuations on scales larger than we thought, seeding these monster structures. Others propose they could be relics of a previous cosmic cycle, remnants of a universe that existed before ours. The idea of a cyclic universe where Big Bangs repeat in an eternal loop is gaining traction as these impossible structures pile up in the data. Then there's the void, an anomaly so strange it's rewriting our understanding of emptiness. In one region of the universe, a vast expanse dubbed the Great Void spans billions of light-years and contains far fewer galaxies than expected. But it's not just empty. The void pulses with faint energy signatures detected in the cosmic microwave background and confirmed by deep space surveys. These signatures hint at quantum fluctuations, ripples in space-time that could be echoes of the universe's birth or something stranger. Some physicists speculate that voids like this might be portals, regions where the fabric of space-time thins, connecting our universe to others in a multiverse. Others suggest they're scars from cosmic strings, hypothetical defects in space-time formed when the universe cooled. These strings, thinner than a proton but heavier than a galaxy, could stretch across the cosmos, vibrating with enough energy to warp reality itself. If they exist, they're a direct link to the Big Bang's violent birth. The quantum realm offers another layer of mystery. At the universe's edge, where light stretches to its limits, we're seeing hints of a fundamental boundary. Quantum mechanics tells us that information, every particle, every event, has a limit to how finely it can be described. The data suggests we might be brushing against this limit, a quantum horizon where space-time itself becomes pixelated, like a cosmic screen with finite resolution. If true, it means the universe has a maximum information capacity, a hard cap on what can exist. This idea aligns with the holographic principle, which suggests our 3D reality might be a projection of information encoded on a 2D surface at the universe's edge. Imagine living in a cosmic hologram, where everything we see is a shadow of a deeper truth. The edge, then, isn't just a physical boundary. It's a limit to reality itself, a place where the universe's code starts to break down. But what about life? The discoveries at the universe's edge are fueling speculation about alien civilizations. If galaxies formed this fast, this early, the window for life to emerge could be far wider than we thought. The heavy elements in those ancient galaxies, carbon, oxygen, nitrogen, are the building blocks of life as we know it. If complex chemistry was already brewing 200 million years after the Big Bang, intelligent life could have arisen billions of years before Earth even formed. Some theorists argue that advanced civilizations might have left signatures in the data, patterns in galaxy distributions, anomalies in the CMB, or even artificial megastructures that bend light in unnatural ways. A recent survey flagged a faint, repeating signal in a distant galaxy cluster, too regular to be natural. Is it noise, a cosmic glitch, or something else? The possibility of alien life, once a fringe idea, is now being taken seriously as the data piles up. The edge of the universe is also whispering about dark matter and dark energy, the invisible forces that dominate our cosmos. Dark matter, thought to be 27% of the universe's mass, shapes galaxies with its gravity, but remains unseen. New observations suggest it might not be uniform. At the universe's edge, dark matter seems to clump in ways that don't match our models, creating dense halos around those early galaxies. Dark energy, the 68% of the universe driving its expansion, is even more enigmatic. Some data hints that its strength varies across space, stronger near the edge than in the local universe. If true, it could explain the Hubble tension and the cosmic flow toward that unseen attractor. But it also raises a wild possibility. Dark energy might be the influence of another universe, leaking into ours through a shared boundary. The edge, then, could be a frontier where realities collide. As we grapple with these discoveries, new telescopes are poised to push the boundaries further. Upcoming missions will map billions of galaxies in 3D, using spectroscopy to trace their motions and compositions. These maps could reveal primordial gravitational waves, ripples from the Big Bang's first moments that carry secrets we can't yet access. They might detect cosmic strings or confirm the multiverse hypothesis by finding more collision scars. Most profoundly, they could uncover evidence that our universe is finite, a bubble with a definite edge, or infinite, stretching into realms we'll never see. Each new map brings us closer to answering the ultimate question: what are we inside? The universe we thought we knew, 94 billion light-years wide, expanding steadily, built from simple ingredients, is turning out to be a wild, uneven, overcrowded place, possibly one of many in a cosmic tapestry we're only beginning to glimpse. These discoveries don't just challenge our science, they challenge our place in the cosmos. We grew up thinking we lived in an average universe, a predictable bubble of space and time, but every new image, every data point, tells us we're part of something stranger. Capacity, something alive with possibilities we can't yet fathom. The edge isn't a quiet, empty limit. It's a frontier teeming with galaxies, black holes, voids, and mysteries that hint at realities beyond our own. Is it a multiverse, a simulation, a cyclic cosmos that reboots endlessly? The answers are out there, encoded in the light, that's just now reaching us. As we keep looking, one thing is clear. The universe is more audacious, more complex, and more unsettling than we ever imagined. And we're only at the beginning of this cosmic journey.